Okay, this video is all about the periodic table. Okay, first off, a little bit about the history of the periodic table. Dmitri Mendeleev was a Russian chemist who was working on organizing the elements that they knew at that time in some kind of logical order. He first ordered them in order of increasing atomic mass, and then he noticed something. Periodically, their properties would repeat. He then arranged the table so that those who had similar properties would appear in the same group, which is called a column on the periodic table. At the same time, Lothar Meyer, who had no idea of what Mendeleev was doing, he was a German who actually created pretty much the same table as Mendeleev. Meyer asked a colleague to review his work before he submitted it for publication, and Mendeleev did not. So Mendeleev beat Meyer to the punch, so Mendeleev gets the credit. Mendeleev's most important contribution, though, was predicting the properties of three unknown elements. I think it was gallium, scandium, and I can't remember the other one. But basically what happened was he said, I think there's an element that is got this property and this property. And later when they found those three elements and that their properties were similar to what Mendeleev had predicted, everyone accepted his work. That doesn't mean the table was perfect, though. Some elements would have to be out of order, or their masses wouldn't work with their properties. So the table was not perfect. That's when Henry Moseley came along. He rearranged the table in order of increasing atomic number instead of atomic mass. And when he did so, all of the flaws that were occurring with the properties being in the correct locations were fixed. So that's the way we have the table today. And there's a term you need to know called periodic law. Periodic law states that when the elements are in order of increasing atomic number, like Moseley had done, the properties will periodically repeat themselves. A couple things you need to know, and you should all know this. This should be dummy work. A period is the elements in one horizontal row of the table. So rows are periods, and columns are groups, also known as families. Elements that are in the same group have similar chemical and physical properties. Other things you need to know, there are A group elements and B group elements. A group elements are called main group elements or representative elements. So if I ask you what the representative elements are, you need to know they're in the A groups. That would be columns 1A, 2A, and then 3A, 4A, 5A, 6A, 7A, and 8A. The B group elements are the transition metals. They are in the middle of the periodic table, and they're highlighted in blue. Other things you need to know. The two rows of elements at the bottom of the table are called the inner transition metals. The first row is called the lanthanides, and the second row is called the actinides. Other groups that I expect you to know. In the dark green on the far left, I expect you to know those are the alkali metals. In the turquoise, I expect you to know those are the alkaline metals. You also need to know the halogens in red and the noble gases in black. You also need to know that alkali metals are soft and they react really easily with water. And halogens are also very reactive. Like when chlorine reacts with sodium, it's very vigorous. The last thing you need to know is that most of the table is composed of metals. Metals all have a luster, which means they are shiny. They are good conductors of heat and electricity, and all of them are solids except for mercury, which is a liquid at room temperature. They're also very malleable, which means they can be hammered into sheets, and they're ductile, which means they can be drawn into a wire. Nonmetals are elements that do not act like metals. They're gases, like chlorine or oxygen, or they're solids, like phosphorus and sulfur. Bromine is the only liquid of the nonmetals, and they're usually hard and brittle substances. Metalloids, or semimetals, are a cross between metals and nonmetals. For example, they are semiconductors, which means they're poor conductors at room temp, but they become pretty good conductors at high temps. When you look at the periodic table, you must be able to find the semimetals. The metals are on the left, the nonmetals are on the right, and the semimetals divide them. You also need to know that hydrogen is a nonmetal. It is not a metal, despite being on the left side of the periodic table. That is it.